Hello everyone, I'm Dan. I'm a cloud engineer with Cloudbase Solutions. Alessandro talked about us, so I won't go into that, what we do, because you have an idea now. Today I'll talk about a project called Kolla. It's an OpenStack project. But first, let me talk about deployment paradigm for OpenStack. So OpenStack, first of all, is an infrastructure as a service. So that's actually quite a lot to cover because it has to take care about storage, networking, and compute, and that's quite a lot. It's everything. It's software defined. People call OpenStack the cloud OS or a cloud ecosystem. And OpenStack, let's face it, it's not the easiest tool to deploy, to manage, to scale. So you have, when you decide that you want to use OpenStack, you have to consider a few things. You have to do an evaluation process. First, the first question is whether you do it yourself, you install yourself the OpenStack, or you go to a vendor and pay him, and he will offer support. He will install it for you. Of course, each has its advantages and disadvantages, which are obvious, I think. After you consider this, you have to consider, okay, I go with RDO, I have to go with I don't know, Juju charms. You have to consider and to think about the deployment tools you will need. After that, you'll also think about the deployment, the automation tools. You want to use Ansible, you want to use Puppet, stuff like that. And also, if the tool you want to use offers bare metal provisioning. Like, let's take, for example, MAS. If you use Juju, you can also use MAS from Canonical. Also, you have to consider how easy it is to manage your cloud after you deploy it. So it's cloud management. So, what is Kolla? Kolla, it's an OpenStack deployment tool, leveraging and deploying OpenStack in Docker containers using Ansible for deploying and managing the OpenStack cloud. So the main idea is to put each OpenStack service in its own Docker container with Ansible, of course, as I said. So at the end of the deployment, each service will have its container. Let's take, for example, Nova API will have its own container, Nova Conductor, Nova Scheduler, Cinder API, Cinder Volume, stuff like that. What we did at Cloudbase and how we use OpenStack, we added the Hyper-V role to the Kolla project. So we upstreamed it. We are waiting for it to be merged into the project. So at the end of the day, you can use Hyper-V as a hypervisor for OpenStack with Kolla. You can, here is the GitHub link for the Kolla Ansible. Why Kolla? Well, first of all, Kolla it's platform and vendor independent. What this means is that no company holds control over Kolla. It's very community driven, and for this I will show you some the code which goes into Kolla. Okay, it's so I have here Stackalytics, and I have opened the code, the commits for the Kolla project in OpenStack. As you can see, no more than 36% of the code it's 99 cloud. I mean it's not over I don't know 90%. And let's take, for example, another project. I don't know, a Packstack, and let's see the commits. Okay, as you can see, 81% of the code of the commits it's held by one company, and this, in my opinion, it's vendor lock-in or vendor driven project, which, yeah, it has its own disadvantages, in my opinion. So this is why one of the reasons we choose Kolla, because it's community driven and no one holds a grip on it. Also, good delivery method. If you take RDO, for example, it installs each packet individually. So this, if you want to deploy RDO and one package gets updated and no longer works with your environment, you're screwed. Okay, it happened to me quite a lot. This actually, at the other end, you have a monolithic. So RDO it's quite granularly, and you have let's say fuel, which is it's very monolithical. So Kolla is kind of in between. Each service has its own Docker image. So let's say you can end up with, I don't know, 30 Docker images for each service. It's easy to deploy and manage. Basically, you will work with 2 files deploying Kolla. First file is global.yaml. Basically, there you specify how your cloud will look like which network interface will go where. This is my, let's say, storage network. This is my Neutron gateway network, stuff like that, passwords. Also, which services you want to enable. Let's say you don't want Glance, you don't want Swift, you want Cinder, for example. And also, a very important thing, you can bootstrap the control plane with Bifrost. Basically, this means you have bare metal provisioning. Bifrost is it's based on Ironic, basically, which is an OpenStack project for bare metal provisioning. Yeah. So this is Ansible. It's an automation tool. It uses roles, playbooks, and templates for automating things. Here you can see a very simple playbook which installs a LAMP server. Yeah, it configures the files it needs. It installs the packages, restarts the services. And also one important thing is that modules, so basically functionality in Ansible, it's with modules. So you have Windows modules. This is very important because then you can use Ansible with Windows, what we are doing. Yeah. Docker is a container platform, runs process containers that can come in form of Docker images. Those images use Docker files for image building or image definitions. Basically, what a Docker image is, it's an executable package from where you can run your specific piece of software, and includes like the code of your application, environment variables, libraries for your application, and Docker. It's implemented with namespaces, C groups from the Linux kernel. Few notes. Kolla, it's not Magnum. With Kolla, you deploy OpenStack in containers. With Magnum, you manage containers from within OpenStack. Okay? And Kolla, it's not OpenStack Ansible. Kolla uses Ansible, but it does not deploy OpenStack the same way Kolla Ansible does. OpenStack Ansible does. Basically, the main difference is that Kolla uses Docker containers and OpenStack Ansible does not. Since Okata release, Kolla Ansible is a standalone project. Before, you had only Kolla project, which hold all the Python management code and also the Ansible roles. Basically, with Kolla, you care about the Ansible bits mostly. So from Okata, you have Kolla and Kolla Ansible. Most of the code goes in Kolla Ansible nowadays. There is where we pushed our code. It was founded during Kilo release, so it's quite stable. It's quite portable. You can use those Docker images with Puppet, let's say. So you're not bound to Ansible. You can use if you have your own project, you can use those Docker images for your own. Kolla tries to have images and to deploy services from the big tent, OpenStack big tent. Of course, there are lots of projects, and right now not all the services are provisioned, but work is done in that direction. But not only, Kolla also deploys stuff like Ceph, which is quite nice. Also like FluentD for logs. Next step in Kolla evolution is Kolla Kubernetes. Basically, what that means is you will have OpenStack as just another application running on Kubernetes. This, of course, resolves lots of issues like high availability, load balancing. It's still in dev phase. There's no stable version right now. Of course, okay, Hyper-V plus OpenStack. I'll talk very little about this. I will be brief. Windows is a first-class citizen of OpenStack. You can use Hyper-V as it has the same process handling as KVM. Basically, from OpenStack point of view, you just have a hypervisor. You just boot VMs, destroy them, attach volumes. You don't care from that point of view if it's KVM or Hyper-V. We started developing, so basically we did the agents, the Nova, Neutron, and Cinder. We ported them on Hyper-V. We started this on the Folsom release in 2012, so it's quite stable right now. Why would you use Hyper-V with OpenStack? Well, it's not that hard. If you want to use, if you have Windows workloads as VMs, it's quite fast. Actually, one quite funny fact is that when I started playing around and working on Kolla, I used VMware as a hypervisor, and then I was forced to move on Hyper-V, and I found out that it's quite good. So I only use Hyper-V now. Also, you have Windows failover clustering. It's a Windows server technology. Let's say you have multiple Hyper-V nodes. You have 2 Hyper-V nodes in a cluster. And by the way, OpenStack does not have to know about this. It's on Windows level, so you don't care about this on OpenStack. You don't have to do any configurations. If one Hyper-V goes down, all of your VMs will migrate to the other Hyper-V, to Hyper-V2. So it's quite nice to have this built in with Windows technology. Also, you have S2D. It's a shared storage technology from Windows, starting with it's called Storage Spaces Direct, and it's available since 2016 Windows Server release. Okay, the deployment workflow. You will, as I talked about Docker images. You will have to have some Docker images. How you can do that? Well, you can pull the already existing Docker images from Kolla Kolla Docker Hub, or you can build your own images and push them to your private registry. You can also have source images or binary images, what this means is that when building your images, it will install packages from source code. One recommendation, I found the source images to be more stable than the binary ones. This is just from my experience with Kolla. Okay, so let's say you pulled the images from Kolla repository or you built your own. The next thing, you have to do some configurations. As I told before, you have only to play around with 2 configurations files, the global.yaml and the inventory file. There you'll specify where each service will go. So let's say this is for Ansible actually. Ansible takes care of where each service will go. I will show this in a moment. And deploy Ansible, which basically deploys roles. As I talked earlier, most of the functionalities is in roles. At the end, what will we get? Lots of containers. As I said, Horizon has its own container, Neutron DHCP agent, Neutron L3 agent, the metadata, the server, lots and lots of containers. Okay, let me show you how easy it's to deploy this. Okay, so if I do a Docker, you can see that I already have some images pulled. I can control which images do I pull from etc Kolla. Okay, it's okay. You can see it fine. Okay. From global.yaml. It is the file I talked about earlier from where you control how your cloud will look. So I have a base distro of Ubuntu. I have the source type. I have 4.0.0, which is a Okata OpenStack. I use by default, Kolla uses by default HashiProxy, so I have a virtual IP address. Yeah. I have the network interface. This is the management interface. Also, I have the Neutron external interface, which is ETH1. Okay. So here's the important bit. If you can see here, I enable services, so it's a long list of services. Here I specify, okay, I want Cinder backend LVM. I want it, yes. I want Horizon for Magnum, yes, and I say yes. Also, what we did is we added Hyper-V, and here I specify enable Hyper-V, yes. If I say this, Kolla will deploy OpenStack services on my Hyper-V. Enable Tempest, Magnum, yes, I want them. Here I specify the Cinder volume group name. And also I have my Hyper-V credentials and vSwitch in which the VMs will connect, okay? So this is the file in which I specify how my cloud will look like, okay? And the second file I talked about, it's the inventory file. And this one looks like this. Okay, so this is an all-in-one deployment. So all the control services will be deployed on localhost. Also, Neutron will be deployed on localhost, the compute, storage, and so on. Here, if I would have a separated network machine, I'll just put the IP there. Yeah. And let me show you the Hyper-V bit. Yeah. Here, I specify that I want Hyper-V services, Nova Hyper-V, Neutron Hyper-V to run on this Hyper-V node. And I have here the Hyper-V credentials, of course. Okay. So now the only thing left to do is to deploy. I told Kolla that I want Hyper-V, I want all-in-one deployment, I want stuff like Cinder, Nova. So now I just have to deploy it. Now Ansible will fire. We'll do some pre-checks to make sure that the ports for the APIs are open, stuff like that. We'll do some time, we'll configure some time services and stuff like that. It configures HashiProxy, as I said before, and we'll go through each service that I mentioned I want to have. So it will go through Cinder. Basically, what it will do is we'll take my already existing Docker image because I already pulled it. Said, okay, run it, do some configurations on it, like network configurations. Also, it does some it mounts some volumes on the container. I will show this. No. Okay. So at the end we'll have containers. Okay. Yeah. So now it's deploying, and I will show you at the end how it will look like. Okay. Service configurations, as I told you, go in etc Kolla. So each, how do you configure each service? Well, let's take Nova for example. I will have to go in etc Kolla Nova, and let's say I want the nova.conf to include another mechanism driver, which it does not by default. I'll just go in etc Kolla nova/nova.conf, and I will edit it, and Kolla will apply it. Okay, I don't have time to talk about host networking. Kolla tools, by default, Kolla contains some tools for an easier management of the cloud. You have a cleanup script, which this is for dev, more or less. I use it a lot when I have an already deployed environment. I want to destroy it. Just for dev purposes, I use cleanup containers. This will destroy all my containers, and then I can run deploy again. I can run pre-checks, which will make sure that my cloud looks okay before of the deployment, like I don't know, API ports are available for the APIs and so on. Post deploy scripts, basically this will create an RC file for my user, and also I have a script that generates passwords for each service before I run deploy. Yeah, I don't have time to go on best practices. If you find something that is not documented, then document it and push it up to the project. This is how a Docker container looks like. So I run docker inspect nova compute. This is the compute container for Nova, and here I can see a JSON format configuration. So I can see network settings, container environment variables, the container state, and all the volumes and mounts attached to that container. This is quite important because how does Nova Compute take its configuration file? It mounts from the host. It mounts etc Kolla Nova Compute, and it will mount it from within the container on var lib Kolla. This is read only, because from within the container you should not be able to write on that configuration file. You should be able to write it only from the host. And for example, if I already have an OpenStack deployed, how do I modify something in its configuration file? Let's say I want for Nova, I have debug to false, and I want it to set to true. It's very simple. From the host, I go to etc Kolla Nova Compute, I edit nova.conf and put debug equal true. After this, the only thing I have to do is only to restart the container. The container will automatically pick up that configuration change and will make notice of it, because this is how it does it, because of the volume attached to it. Upgrades. I find it quite easy to do major and minor upgrades with Kolla. It supports XYZ format for versioning. Let's say Liberty was 1.0, Mitaka was 2.0, Okata is 4.0. If I want to upgrade from 1.0 so let's say I have an existing environment of Liberty, which is 1.0. I want to upgrade it to 1.1 minor release. But what will I do is just go in global.yaml and modify OpenStack release from 1.0 to 1.1 and run Kolla Ansible upgrade. This will automatically tear down the existing 1.0 container and will start the 1.1 container. Works both for major and minor versions. Yeah, I will show you now how my environment looks like. Okay, so it's not yet finished. I have a second demo environment in which I already have the OpenStack deployed. So let me show you how it looks like. I'll do a Docker PS. This shows me all the running containers. Yeah, so there are quite a lot of containers. I don't know. They're all running. Okay, let's see the Nova services. So I do Nova. Okay. So you can see Nova Scheduler, Nova Conductor, Nova Compute from the KVM, and Nova Compute from the Hyper-V. Each of them are running in a container, of course, like I talked earlier. So yeah, basically this is what we did. We added the functionality to this Hyper-V. Also, there's Neutron. If I do Neutron agent list, I can see the Hyper-V agent running right here. Okay. So let's launch a VM because we love Horizon and graphical user interfaces. I'll do it from here. Okay, so this is my existing environment with Kolla. Okay, I have a already running. Fuck it. Okay. I'll just launch a new VM. Okay, I don't want to use. I'll use zeros for simplicity. I'll use a small flavor. And I'll attach it to my private network. Okay, I'll launch VM. The image is building. Actually, we also deploy free RDP for Horizon integration with Hyper-V, so we can take a look at the console of the VM running on Hyper-V. Okay, so it booted, as you can see. We are waiting for it to take an IP and ping 888. Why not? Okay. And it works. So I have also internet connectivity. Yeah. If I do Nova list, yeah, I can see my VM running. Okay, if you have any questions. Yeah.
You mentioned that you can do upgrades
Yeah.
using Kolla.
Yeah.
Can you also use Kolla to install new modules if you want to? Like you want to add Ceph to your OpenStack or
Of course.
something like that. Can you do it
Yeah.
via Kolla?
Yeah, so Kolla implements functionality like services, Nova, Cinder, Ceph via roles. And there exists a Ceph role for Kolla. Let me just show you. You can mention it in here. Etsy Kolla global.yamls. I showed you before, okay? Here, can you see it?
Yeah, but I mean to add it later.
Yeah.
You install
Yeah.
OpenStack,
Yeah,
you
of
just
course.
want to add Ceph,
Good question.
later on.
Yeah. So how Ansible works is it's that you run it once. You make some config changes. Let's say you added in the inventory file, you added a new storage node. The inventory file is the file Ansible uses to know where to deploy stuff. Okay. So you add the new node there. You rerun Kolla, and how Ansible works is that it looks okay. I already have this installed on this node. Okay, go on, skip this task. Go on, and then said, okay, this is a new node. I don't have anything installed on this, so I will install everything I should have installed on it. So this is how it works. It will not reinstall and redeploy the existing stuff. It will go over to the new stuff.
Okay, so in the same way you can add compute.
Exactly. Any service. Yeah. Any service Kolla uses. Yeah.
What happens if you enable one service and then you disable the service? Because Ansible is bad at rolling back.
Yeah, good question. I never used this scenario, and I never thought about it. Good question. Oh, I guess,
You could clean the node.
yeah, clean the
Disable the
man.
node
Yeah,
completely and
yeah.
redeploy it without the.
Well, if it's one whole node, it's simple. You just shut it down. But let's say you have a service on the node running other services. Well, you can just shut down the container. This is quite powerful because and granular, and this is quite great because let me show you again the container. The container is running. Yeah. So let's say I want to take out Cinder. If I want to take out Cinder, I just kill this container. Okay? And every container that has Cinder scheduler, Cinder volume, backup, I just kill the containers, and Cinder will just go away.
But the system, when you run Kolla again, or Ansible again,
No, because I can disable it from the configuration file from global.yaml.
but if you disable and run Ansible, you will not do that. You have to do it.
Yeah, I think In that case, I think it's.
If you disable them, it will just not take effect of all those anymore.
Yeah, I think so. I'm not 100% sure, but I think this is the case. Yeah.
Why did you go with Ansible? It's a very generic
Uh-huh.
question. Why not Chef? Why not Pod?
Uh-huh, uh-huh.
Why Ansible?
Good question. So I find this is just my personal opinion. I find Ansible much user friendly and much easy to get into. And I guess when Kolla started, the guys developing it had the same idea. It's much simpler to use, in my opinion. It's much, I don't know, less error prone. I mean, for this scenario, I guess. Yeah. I found it more easy to do a dev on it, to implement what we did at Cloudbase. Yeah. Any other questions?
Yes, let's say that you want to deploy on a non-all-in-one scenario. So
Yeah.
you have two
Yeah.
physical servers.
Yeah.
You have that inventory file
Uh-huh.
where you specify the IP address of the, let's say, the second server.
Yeah.
So that means that the actual second server already has an IP address, so it already has an operating system, no?
Yeah.
So the concept of metal as a service
Yeah.
is not applicable in this case, no? Because you don't bootstrap the metal box. You don't install
You have. Yeah.
as a prerequisite, you have to have an IP on it.
Yeah.
And, maybe some
Sorry to
SSH or
interrupt you.
Yeah.
We can discuss this afterwards.
Yeah.
We can discuss it one-to-one because it's very
Yeah.
technical and we have another presentation. Okay? Sorry.
Okay. Thank you.
Thank you, Dan.
Thank you.